Everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So we are asked to find the longest subarray with the maximum bitwise AND. Okay. So the title of the question is only sufficient for the whole description of the question, in fact. So I want to find a longest subarray which has the maximum bitwise AND. Okay, out of all the subarrays which exist, I will pick the one which has the longest AND value. So AND of all the elements, and I want to largest AND value, and I want to return see that what is the uh, largest possible length of such subarray with that particular AND, with that particular maximum value of AND. So you know the bitwise AND of all AND of array is the bitwise AND of all the numbers in it, and a subarray is a contiguous sequence of elements within an array. It should be continuous. So if you try to observe something here, what is the answer of this 1, 2, 3, 3, 2, 2? The answer is 2. The maximum possible bitwise AND is 3, comma 3. Okay. If you do 3 and 3, you will get 3, and that is the maximum value. So, if you try to think in something that what exactly is bitwise AND? This problem becomes very simple. Okay, what exactly is bitwise AND? If you perform an AND with 1 and 0, you get 0. If you perform 0 with 0, you get definitely 0. You get, if you perform only with 1 and 1, then only you get 1. Otherwise, if you perform something like this, it's commutative and you get 0 again. So I hope you understand this. The value is always either decreasing or it remains same. Okay. So if you perform a bitwise AND, either it remains same or it decreases. Okay. So that is the specialty of bitwise AND. And if you try to perform the bitwise AND of two elements, let's say 3 and 5. So what will you write 3 in binary? You can write 0, 1, 1. And 5 you can write in binary as 101. And if you try to perform a bitwise AND of all the elements, 1 and 1 is nothing but 1. These two AND will make 0. These two AND will again make it 0. So you will get 1. Okay, so 3 and 5 is 1. So if I am trying to say that whichever element you will obtain in the answer, that will be less than the minimum element among this. Okay, less than or equal to. So if you have some number like this, okay, uh, something like this, and it has always one in this. Okay, and let's say this, if you try to do the bitwise AND of these two elements, you see you will get 1 0 1 1 0 0 1. You get the first element only. So it is possible that in the bitwise AND, among the minimum of these two elements, this first element was the minimum, and you get the minimum value only in the answer. Okay, but you cannot get something which is greater than minimum. So what do I want to say basically is that is very simple. If you performing bitwise AND of two numbers x1 and x2 and you get some answer, then you can always say that answer is always less than or equal to minimum among x1 and x2. So I hope you get this. Okay, why exactly this is happening? Because it either remains same or decreases. So the minimum value also decreases. So you see 3 and 5, it literally became 1. If you try to add 3 and 4, you will get something which is much less. Okay, you will get 0, because this is 3, this is 4. You try to perform an AND, you get 0 0 0. So all zeros you get, so this becomes 0. So you see, answer, your final answer is always less than or equal to the minimum of x1 and x2. So what do you understand from this? What do you understand from this statement? Let's say you have an array. Let's say you have an array where the elements are something like 5 5 6 8 8 2 1. Okay, so always the subarray with the maximum element, so this subarray, let's consider this subarray with single element, this has the maximum value of AND, maximum AND. Now if you perform the AND of 8 with some other element, any other element, you will get it less than 8, because some other element is also less than 8 here in this case. So that is less than equal to 8. But what if in the same example, in the very similar example, there was something like this present: 6 8 2 1 8 8 8? Then what will happen? You see, now you see the maximum element is again 8 here. Okay. So maximum element, if you observe, that is still 8. So the sub array must contain only 8s. Okay. Sub array must have only 8s. Subarray must have only 8s, because if you take anything less than 8, the answer will be even less than or equal to that value. So and subarray will have only 8, and if you consider this subarray 8 comma 8 comma 8, this whole subarray, if you try to consider this, this is giving you the maximum value of AND, because you cannot go something which is above 8. Okay. You will, if you do AND with any other element, any two elements x1 and x2, as I had just now told you, you will get an element which is less than or equal to the minimum of this. You can never get an element which is greater than the maximum of this, something like that. Okay. So you select the maximum element and tell that my subarray will contain only those elements, and if there are some continuous sequence of and of that maximum element, then you choose the length. Okay, so here length is equal to 3. You see there are 3 length, and if you do something like 8 and 8 and 8, if you keep doing it, you will get 8 only, which is the maximum value of AND, which is also the maximum element in the array. So one thing you can do very easily for this problem is, for step 1, you just search for maximum element, search for maximum element in the array. Okay. So and then find length of find length of largest continuous sequence of maximum element, largest continuous sequence of max element. Okay, so that's what you need to do in this problem. You see, you what did you do here? You searched for the maximum element, you found that the maximum element is 8, and then you found the largest sequence of maximum element, which is 3 eights, and answer is 3, because the length is 3 here. So it is very similar. You can see in the example also, the largest value is 3, and the length of the continuous subarray of 3 is 2. And similarly here 4 is the largest value, so answer is 1 only. Okay, so I hope you get it easily. This is a really easy problem. If you can understand bitwise, and then you should be easily able to do this. Okay, so this is a very simple problem actually. So what will I do? I will first of all find the maximum element in the array. So I will just iterate through all the elements in the array and just calculate the maximum one. Okay, so maximum one, I just got it very easily. Then what will I do? I will have a count which will count what is the current number of elements in the continuous subarray. Okay, current number of maximum element, and what is the max count. Why I am doing the max count? Because if you see, let's say there was some example where 5, 5, 6, 8 is there, then again 1 is there, then again 2, 8 is there, and then again 2, 3, and then again 3, 8 is there. Okay, let's consider this array. You see, one count of the largest element is having 1 length, this is having 2 length, this is having 3 length. Okay, so out of the count, so count variable here, you will store 1, it will store here 2, here 3. So we need to find the maximum count on also, because we need to find the maximum length of the subarray, and that must contain only the maximum element. So this maximum count we need to take care of also in the array. So count and maximum count, two values I take it easily, and the remaining things becomes really simple. Okay, so uh, I traverse through the loop. And I will check that while I will keep checking that while my I should not. This is the safety criteria which we should always mention, and nums of I should be equal to maximum element. Till this is there, you just keep incrementing I as well as you increment the count. When this is over, you reset the count to 0. But wait, you need to update the max count also. So you first update the max count and then reset the count to 0. So you see, you have done it, and what you need to do is very simple. You just simply return this max count. Okay, so I hope you get it easily. I hope you are able to get it easily. This is not at all difficult problem. This is a very simple one, in fact. So let's try to run it and check. You see, we have the accepted thing. If we try to submit it, you see, we have got a pretty good runtime complexity with 100% bits. Memory complexity is showing less, but uh, the time I run it just before it, see, it's changing to a lot. Okay, so that's not much reliable. You can understand. So yeah, That's all for this problem. It was definitely medium easy kind of problem for today, but I hope your day goes really really easy. Thank you so much.